probabilities using counting methods, right? So just a reminder, probability is equal to favorable over total. Probability is equal to, I would say favorable, but it's the number of favorable outcomes unless we're doing the Peter's milkshakes, then it's the number of favorable outcomes. But that's not a probability. Over the total number of outcomes. Okay, so it's the number of favorable. Now, favorable just means that's the thing I wanted to happen, not that that's the good thing. Right? So favorable outcomes probability could be the probability of failing a class, right? Is, in which case favorable outcomes are the failure. Okay? And the total number of outcomes. So if we did odds, remember odds in favor are the number favorable to unfavorable. And probability is favorable over total. So, the word counted. Just do some examples. The word. Counted has been spelled using Scrabble tiles. Using Scrabble tiles. We need a little circle R up there, right? Tiles. Two tiles are randomly chosen, one at a time. Randomly chosen. One at a time. So one followed by the other. And placed in the order they were chosen. They were chosen. Determine the probability that. So we're going to do two sub questions, right? Okay, so if we did that, then everything but that last sentence would be thrown into a box saying use the following information to answer the next two questions. I would say the word counters was spelled using Scrabble, registered trademark tiles. Two tiles are randomly chosen, one at a time, placed in the order they were chosen. Then you get the first question, which in this case is determine the probability that A, you get a C followed by an O. Okay, so you've got these 1, 2, I gotta count 1, 2, 4, so you got these 7 tiles. Okay, so we have 7 tiles. Okay, and we want to know, I'm going to draw 2 of them one at a time. I'm going to put them down in the order they were chosen. So what does that imply? The order they were chosen means we're looking at a permutation as opposed to a combination, right? Permutation, order matters, right? It's got to be a C, then an O. So if we do this as a permutation, then how many C's are there from which we have to choose? There is but one C. And we want all of the arrangements of that one C taken one at a time, which is just one P1, or really just the number 1. And how many O's are there? And we need the O's, which is also one P1, or just the number 1. But how many arrangements are there where the order matters of 2 of those 7 tiles? How do we do that? Take a guess, low cost. Just be wrong in front of, whatever, 30 people. If you... How many arrangements are there of 2 out of a group of 7 where the order matters? What do we say? How many are we choosing from? 7. Permutation or combination? We're going to use the letter P, 7P2. Sure, got into dentistry. I'm still pulling teeth, but it doesn't pay as well. Like pulling teeth. 7P2. Okay, so 1P. Now, it could be written that way. They might just want you to actually state the probability, so the answer could be given as a number, in which case it's 1 out of 42. You could do this using the fundamental counting principle, right? So you could say, all right, I need a C, followed by an O. There's one C and one O. And down here, I'm choosing 2 letters, so it's 7 times 6, right? Well, sorry, 7 and 6 go here. So there's 1 C, 1 O. It's got to come on. There's only one. Of all the ways that I can arrange 2 tiles out of that group of 7, there's only one that is CO. But there are 42 ways to arrange those tiles, right? I have 7 choices for the first tile, 6 for the second, 1 out of 42. So if they gave the answer as 1 out of 42, if you worked out the answer as 1 out of 42, but the answers looked like this, they were in this form, you just have to figure out which one of these guys is equal to 1 out of 42. And, what if 7C2 or 7C something was down there, or some expression that also gave you a 42, but used combinations? You'd have to say, wait a second, I can reject that. I know this is not a combination, because I know the order matters. Okay, so it's a permutation. B, both vowels. So let us remind ourselves. So I need to choose, I need all the arrangements of 2 vowels where the order matters from a set of how many vowels? So how many vowels are there? 3. Okay. So how do I get the arrangement of all arrangements of 2 vowels from a set of 3 where the order matters? Really? I'm just shutting the course down. Just learn the rest of the stuff yourself. I'll see it in there. So 3P2 over 7P2, right? I have 3 vowels. I need all the arrangements of 2 of them where the order matters. And the total number, right? So the only difference between that's stuff we could have done, right? This comes from another unit, 3P2. How many ways are there of arranging 2 vowels from a set of 3? Or I want to choose 2 vowels from the word counted. I want all the arrangements where the order matters, right? And you have to be able to come up with 3P2. But now it's probability, so it has to be favorable. This is the number of ways that I can arrange 2 items from a set of 3, so the 2 vowels from the set of 3, over 7P2, which is all possible arrangements of 2 letters from a group of 7. Okay, moving on. So a lot of these questions are going to look a lot like ones that we've done before, except you're going to see probability instead of the number of, right? So when we did counting, it would be the number of ways that this can be done. Okay, well, we still need that. But on the bottom, then we need the total number of ways that this can be done. An athletic council. Decides to form a subcommittee of 7 council members. There are 9 males and 6 females on the council. Determine the probability. The subcommittee consists of Okay, and we're gonna do 4 different scenarios, right? Now, on a quiz exam, you're not gonna get 4 different scenarios. You're gonna get 1 scenario. Exactly 3 females. A. Exactly 3 females. Okay, permutation or combination? Does the order I choose the people matter? No. So it is a combination. I want to get exactly 3 females. How do I do that? How many ways are there of getting exactly 3 females? 6 choose 3. Well, there's 7 people on the committee, so what follows 6 choose 3? 9 choose 4, right? Because then now we got exactly 3 females. We've dealt with the 6 females. We got 3 of them. There are 9 remaining people. These are the males, right? We need 4 of them to make 7. Okay, so last unit, that's where we stopped, right? How many ways are there to form this subcommittee? But this is what's the probability that? So on the bottom, what do we need? $15, choose 7. The probability is favorable over total. Favorable, 6 choose 3. That's how I get my 3 females. Then I need 4 males. This is the number of ways that I can get exactly 3 females. But it's probability, so I need to divide that by the total number of possible committees. So if you think about it, it's okay, without regards to whether male or female, there are 15 people. We are forming a 7-member subcommittee, so 15 choose 7. Now that's going to be the denominator of everything in here. No matter what I ask, the denominator is going to be 15 choose 7, right? Because that'll be the total number of committees that are possible. So what if we say at least 6 males? So now we go back and we're going to start thinking, okay, if I have at least 6 males, then how many males do I have? 6 or 7, right? Okay, how do I get 6 males? 6 or 7 males. So how many males are there? How many do I want? 6. And how many females am I going to get? And how many ways are there of getting them? 6. Okay, top numbers add to 15, right? Because there are 15 people. Bottom numbers add to 7. I need 7 of them. Okay, or. What do I put for or? What do I put for or? What operation? Plus. Think of this. I need 6 males and 1 female, so we multiply. Or I need, how do I get 7 males? Do you need the 6 choose 0? No. So, if the answer is given in combinatorics notation, which in other words looks like that, maybe you see 6 choose 0, maybe you don't. Okay. I like putting it in because then I know that, okay, look, all 15 have had their chance and I've got my 7 of them. What goes in the bottom? 15 choose 7. Now, this could also be written this way. Okay, so that's the other way, right? I mean, you can write it using the bracket notation. Do not put a line in between the numbers. Otherwise, it just becomes a fraction inside a set of parentheses. Okay, which, if you're lucky, I'll ignore if I asked you to determine, but I'll probably ding at least a half mark. And you won't have that problem on the test. But on the test, if you should see a set of parentheses, the 2 numbers, and a division bar between them, you say, no, that's not the correct notation for this, right? then remind me next time I go to write a set of questions, because I want to throw some stuff in. You know, the only difference between two answers will be, hey, I'm going to throw some division bars in there. Right? So one of the big things when you're doing multiple choice, examine all four answers. Don't just look at A and go, A is it. Yeah, that's good, right? It's like A. So A looks like this, right? You say, yeah, 9 and 6. Oh, yeah, okay, this is it. The answer's it. No, that's not the answer there, right? Because you don't have those things. And if you looked at D, then you would see something that looks like this. And this, and this, and this, and this, which is the correct answer, right? So if you look and there's two, hey, those are almost identical. Like, what's the difference between these two? You need to look at all the possible answers in multiple choice, right? It's very easy to choose the wrong one if you're not looking carefully, right? You don't say, well, wait a second, there's two that, they almost look identical. What's the difference between them? Why would they put both answers there? C. Ms. Clark is on the subcommittee. Is there an E on the end of Clark or no? Yeah? Okay, so what do we put? Oh, I'll tell you. Fill it in. Figure it out. Fill it in. Low cost. Put, do it in pencil, just in case. Okay, now you got, is that right? Why is that right? Or not right? There's only one Ms. Clark and we need one of her. Then why 14 choose 6? Yeah, so there's 14 remaining people. We don't care about how they're chosen, right? Really, it doesn't matter whether they're male or female. There's 14 people left, and we need 6 of those. Over 15 choose 7, right? Because that's the total number of ways that we could choose a 7-member subcommittee from a group of 15. Ms. Clark and exactly. Actually, Ms. doesn't have a period, does it? Okay, figure that one out. We want to have Ms. Clark and exactly 3 males. Oh, by the way, you might not see the 1 choose 1, right? So you might just see that right, it's 14 choose 6 over 15 choose 7. Right? Or they might just give you answers, in which case you'll never see any of those. There'll just be some numbers there. Or it's numeric response, and you're just rounding it to the nearest hundredth, or because it's a percentage, and usually you round those to hundredths. So, say something. Yes. That's fine. Don't do that, but that's fine. You're not going to see that, right? Just keep that in mind. If you see stuff on it, it's going to look like that. Derwin.
If there's an extra person on the
Oh.
6 choose.
So what should it be?
5.
Should be 5 choose 3. Why?
There's already 10 people, like 1 and 9. Should be
Yeah, if you add up the numbers up top, either, hey, now there's 16 people, right? So what happened? Well, I've already done, Miss Clark's already there, right? There's only 5 remaining females. So that's 5 choose 3. Okay. Sorry, I did that one on purpose. Okay, so 1 choose 1, that's Miss Clark. You might not see that in an answer, that might not be there, right? If they give the answer in combinatorial notation, probably won't put the 1 choose 1. 9 choose 3, that's my exactly 3 males. right? Then what? Well, okay, Miss Clark's on there, so there's only 5 remaining females, of whom I need 3, because Miss Clark's on there, so I've already got one of my 7 members. And it's a probability question, not a counting question, so at this point then I have to put it over 15, choose 7. Okay. Without this, that becomes how many ways are there of choosing 7 members of a committee where Miss Clark and 3 males, exactly 3 males must be on the committee? And that's what that question is. Which is a perfectly valid question, right? Like, there's nothing wrong with that. Right. More. There are 10 runners on the cross-country team with roughly the same ability. The coach has decided to choose 4 runners to run in the first race. Annie and Bobby are on the team. Determine the odds in favor of Annie and Bobby both being chosen to run. Okay, so one more time, only with visible words. There are 10 runners on the cross-country team. All with roughly the same ability. Coach has decided to choose 4 runners. To run in the first race. Annie and Bobby are both on the team. Determine the odds in favor. Odds in favor of both being chosen to run. Determine the odds in favor of both chosen to run. So the way we're going to do this is, well, we got to use counting methods. You can't count and do odds, but you could count and do probability. So we're going to work out the probability of this, and then we're going to convert the probability into odds. Okay? Now remember, probability is always favorable up top. Okay? And then total on the bottom. So if I said odds against, you would have favorable, and total, you would have to find unfavorable. But this is not odds against. So we still do need unfavorable. All right, so the first thing we got to do is we got to choose Annie and Bobby. So how many Annies are there? Right. Do we care what order Annie and Bobby get on the team? No. We may care about the order in which they finish, but to choose them, we don't care about the order, right? It doesn't matter. So there's one Annie, and there's one Bobby. And how many people are left on the team now from which to be chosen, or from whom to be chosen? So there are 8 remaining, right? There's 10 on the team total. I've got Annie and Bobby sitting over there. You've been chosen. And how many of those 8 people do we need? And how many ways are there of choosing the team in total? 10 choose 4, right? 10 choose 4. Okay, and so I'm just using C notation instead of the bracket notation. You might actually see the C notation written with multiplication signs in between. Like you might see 1C1x, right, for time symbol, 1C1x, 8C2. You might just see 8C2 over 10C4. So now we need to work this out, right? We need to get So just using raw numbers, working this out, we get 28 out of 210, right? 8 choose 2 is 28, 10 choose 4 is 210. Now we need that as a reduced fraction. So we say, well, okay, what goes into 28 and 210? I mean, 2 does. So it'll be 14 over 105, but then 7 goes into both of those, right? Or you could just plug it into your calculator and just say reduce this for me. Wait, sorry, it's 15. Okay, so you just go 28 divided by 210, math, enter, enter. Okay, and that'll convert that. You'll end up with 2 15ths. So what are the odds? 2 to 13. Right? So odds in favor. 2, favorable. This is total. We need unfavorable. So 15 minus 2, 13. These two guys have to add up to the total number, right? That's got to be the 15 people. What are the odds against? 13 to 2. How would you work that out? You would do the odds in favor, and then you would turn it into odds against. So if they asked me for odds against, I would do the probability. I would turn that into odds in favor. That's easy, and then I would flip it. Okay? It's an extra step, because you could do the probability and then just go straight to odds against, but yeah, then you got to do 2 different calculations, right? You know, the extra time it takes to do it this way, not much time at all, right? So you'll get the answer, you'll get there faster. You could see it as 28 to whatever 210 minus 28 is, and a 10, and then 18, like 182 or something. Okay, so you could see it as 28 to 182. You could see that reduced. Could be 14 to 91. You could see that reduced. It could be 2 to 13. Okay. So it depends on the numbers they use, right? If you're just going with the 28 and the 210, you say there's 28 favorables, 182 that aren't, and they're not giving it in a reduced form, it comes like this way. You're sitting there looking at this and looking for the answer. It's like, oh, I got it wrong. Well, then just work this out as a decimal and then work out each of the answers as a decimal and say, well, only one of them is the same, so that must be the answer. Work out all 4 if you're going to do it that way, because maybe 2 of them are the same and you've got to figure out why one of them isn't the answer. Okay? Like that's the distinction they're making. All right. Poker hand. Okay, here we go. Right. Poker hand. They won't ask this on the test, but you should know. All right, so is everybody sort of familiar with the game of poker?
Yeah.
So you have a deck of 52 cards. You're going to make a 5-card hand. Okay? Now, you may have seen like on TV, which is, what's that called? Texas Hold'em? Or what do they do? What's that? Texas Hold'em or something? So in that, you're given 2 cards, and then a whole bunch of cards come up in the middle, and you make your best 5-card hand from the 7 cards that are, or 5 cards that are on the table and the 2 that you have. And then whoever has the best hand wins. And you have a round of betting in between. But giant poker just started out as you deal, everybody gets a 5-card hand. You pick up those cards, you rearrange them in any order you want because it's a and not a. So when I deal you 5 cards, what is it? It's a combination, not a permutation, right? The order does not matter that the cards come. Now, in a sense, if you're doing Texas Hold'em and cards are coming, the order does kind of matter, right? Because you might drop out before you don't know, right? I mean, it's incomplete information. Everybody's playing with the same information, but it's incomplete. You don't know what's going to come out in the middle. But if you're dealt a 5-card hand, you're just playing that way, so it's sort of normal poker. Then there's ways to rank the hands, right? Because you have to determine who's the winner. And those are based on probabilities. And probabilities are based on counting how many ways can this happen. Okay? So the most likely thing is you got nothing. You have a high card, right? Like one of your cards is the highest card in your hand, but other than that, you don't have a pair of cards. You don't have all cards the same suit. You don't have all the cards so that they're running in order, like 7, 8, 9, 10, 7, 8, 9, 10, Jack. You don't have, right, 3 of one kind and 2 of another. These are all different hands in poker, right? And it's just all the different ways that you can group the cards somehow. And the poker hands, the way they come out is based on these probabilities. All right, so what's the probability of getting 2 pairs? So to get 2 pairs, so we did this the other day, right? We said, well, how do you figure out how many pairs? But the question then was just, what's the number of ways you can get 2 pairs? So we said, well, it was 13 choose 2, because you got to choose which card, which ranks you're going to get the pair of, right? So there are 13 ranks from which to choose. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, and King. We need 2 of those. Once I've got those, then within that first set of 4 cards, I need 2 of them. Within the second set of 4 cards, I need 2 of them. And there are 44 cards left, right? Because I can't pick from the ones I already picked from. If I do, I'll end up with a full house, which is 3 of a kind and 2 of a kind. So that's just the number of ways that you can get 2 pairs. To do probability, we then need the total number of poker hands, which is expressed how? 52 choose 5, right? There are 52 cards, and you are choosing 5 of them. So you can work this out, and in raw numbers, like if you just work out the top and write down the number, it's 123,552. So 123,552 of all the available poker hands are 2 pairs. And the bottom number, which is the really important number, right? It's like, so how many different hands are there in poker? 2,598,960. Okay, so if you're playing poker or any game where you are dealt 5 cards from a set of 52, there are 2,598,960 combinations, right? In other words, rank, groups of 5 cards. We don't care what order they came in, because we'll take them and arrange them ourselves. Thank you very much anyways. And this works out to, so as a reduced fraction, 198 over 4165, which is really about as useful a way of expressing that as the top one, which is to say, that's not at all useful, right? Give me a decimal or a percent. So 0.0475, put that into terms I understand, 4.75%. Okay, so almost 5% of the hands, or about 1 in 20, is 2 pair. So now, we pauses. Oh, damn it. Scroll down here. All right, so let's take a look. We were looking at 2 pairs, right? Okay, I think the page just hasn't loaded yet. Oh no, there we go. Somewhere down here. Oh, really? Hand category. Yeah, here's the. Well, there's a better. Well, there's. Oh, yeah, okay, there's some probabilities there. There was one that had a table. But okay, we'll just go down to 2 pairs. Flush, straight, 3 of a kind, 2 pair. Okay, well, that's okay. In 5-card poker, 123,552. Hey, we've seen that number before.
Wow.
Possible 2 pair hands, and they don't actually give us the probability. Oh, look, here we go. 13 choose 2, kind of little weirdish notation, right? But 13 choose 2, 4 choose 2, 4.7, 120. Look, right? That looks just like the stuff you wrote. Okay, so that's how it's done, right? That's how all of these are figured out. It's just based on probabilities, based on counting methods, right? So never say, when are we going to use this? Yeah, you go gambling, you better know.
What about all the other factors?
Do one more. Let's do a full house. What's a full house consist of? What?
Wait, oh.
No, okay, somebody knows poker. What's a full house consist
Pair
of?
and a triple.
Okay, so 3 of a kind and 2 of a kind. It's actually easier to figure out. So a full house in poker is 3 of a kind and 2 of a kind, also known as a pair. So you got a pair, and then you've got 3 of a different kind. So, where we're going to do it much the same way, right? 13, well, not 13, choose 2 though, right? Because we need to first choose which one we're going to get 3 of a kind of. So how many ranks are there to choose from? Ace 2, 3, 4, 5, 6, 7, 13. All right, there are 13 ranks, so I need one of them. That one is going to be the one I'm choosing 3 of a kind. So we'll go 4, choose 3. How many ranks are left? There's 12, and I need one of those. And of those 4 cards, how many do I need? 2, because now I'm going to choose my pair. So I choose which rank am I going to get 3 of, and then which rank am I going to get 2 of, and then we're done, right? Because we've got 5 cards. So we don't need to say 11, choose 0. Hey, there's 11 cards, 11 ranks, you're not going to choose any of, right? We just leave it as that. Over 52, choose 5. Which works out to 3744 over, same deal, 2,598,960. So if you remember, excuse me, it's about 2.6 million, right? Over 2.5 million different possible hands. This reduces to 6 out of 4165, which is 0.00144 or 0.144%. So way less than 1% are a full house. And if we go back here and scrolls up to look for full house, so 2 pair, the next highest ranked hand is 3 of a kind, which comes in at 2.11%. Then there's a straight, which comes in at 4.62%. Oh wait, sorry, that's 7 card. Comes in at 0.39%. Then there's a flush, which in 5 card comes in at 0.196%. And then there's a full house, which comes in at 0.1441%. Okay? So, way less than 1% of the time, right? Most of the time. If you look at high card, which is just, I got nothing, I don't have a pair, I don't have 3 of a kind, I don't have any of this, that, or the other, that actually comes in at the highest frequency. Look up the page yourself and find it. That actually comes up about half the time or over half the time. So 1 pair, that's 5 card. 1 pair, 42.26% of the time, and a high card, aka nothing much, 51.11% of the time. So about half the time you're not going to get in, right? All you have is a high card. Now, the way that those are ranked is if your high card beats the highest card that somebody else has, you win. Right? So within each of the things, like 2 pair, the higher pair wins, right? So there's a way to break, but it could be a tie, right? So I got a pair of kings and a pair of queens, and so do they. Then it goes down to the next card, the last card that remains. Whoever's got the highest one of those wins. If they're the same, then it's a tie. Okay? Now we hold the bio. Oh, sorry, that's right, if there's a tie. Okay, so enough poker. Don't gamble. A password is made up of 3 letters followed by 3 non-zero digits. Non-zero digits. It may help you when you go to write the poem if you bring a highlighter with you and maybe you highlight like non-zero or something like that, right? So like as you read through, remember you got a ton of time to do this this exam. So you can like read through a question and then go through it again with your highlighter and just sort of highlight stuff, like round it to the nearest tenth or whatever, right? So just you're making sure you're rounding correctly. Or in this case, maybe highlight non-zero digits. Okay, so I need to know something about those. Determine the probability. Probability that a password contains ABC in any order if both letters and digits Okay, so we do this two ways. A, they can be repeated, and B, they can't be repeated. So A, letters and digits can be repeated. So in other words, you could have AAA999. And they can't be repeated, so you can't have AAA999. You can't have AAQ anything. So can be repeated, and B, can't be repeated. Okay, so very important that you understand, is there repetition or not, right? That's how you're going to set up your calculations when you do it. So, can be repeated. In this case, we're going to go with fundamental counting principle, right? Permutations isn't going to work, so we go with fundamental counting principle. Okay, so we say I need, what is it, three letters followed by 3 non-zero digits. So letter, 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 digit, digit, oh, never mind. Letter, 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 digit, digit, digit. Over, well, on the bottom we got the same thing. Letter, 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 digit, digit, digit. Three, 6. All right, so generally speaking, if repetition is allowed, you're not using a permutation or you're going to use fundamental counting principle, right? Okay, how many choices do I have for the first letter? 3, right? It's either an A, a B, or a C. For the second letter, then 2. And for the third letter, 1, right? Because we got to get A, B, C, right? So it could be like ABC or ACB or BAC or CBA or 3 factorial ways. They can be, but I have to have ABC, so they can't be. So the can be repeated is going to come in down here, right? Then we're going to say, wait a sec, but you can repeat. Okay, followed by 3 non-zero digits. How many non-zero digits are there to go here? 9, and here? No, we can repeat. And here? So 999. Okay, so we have to have ABC, so that became 3, 2, 1. We have 3 non-zero digits, so there are 9 digits from which to choose, and we can repeat them, so 999. Okay, what goes on the bottom? How many letters can we choose from? Oh, this is the total number. This isn't the, you gotta have ABC number. The ABC is a restriction. This is, hey, how many ways can you generate a 3-letter, 3 non-zero digit passcode if I can repeat letters? Sure. How many go in here?
26.
26. How many go in here? How many go here? Here? Okay. So half the test consists of this stuff, right? It's going to seem like more than that by the time you're done writing it, but half the test, right? And whether it's probability or counting or set theory, they're all pretty similar stuff. So just make sure you're reading carefully and understanding and take your time doing it.
Why is it 321 and not 333?
Because I have to have ABC.
They said it can be repeated.
Not if the password. The password has to contain ABC in any order, so I can't repeat those. Well, so the password contains ABC, right? Circle in any order. Okay, so that tells you ABC, ACB, BAC, BCA, CBA, CAB.
For an example, you said it could be
Yeah. I said if it can be repeated, it could. I said it can't be AAA 999 because you. Okay, sorry. Right, strike that. I don't know. Go rewind the video and say, see here, 35 minutes and whatever you messed us over. All right, let's fix that. If you're still with us after all this time, which is highly doubtful, anyways, these things get no views. Hey, that's okay. Okay, so I have to have an A, B, C, or CBA, so I must have those three letters. So this can be an A, B, or a C. Then depending on what's left, there are two letters, then one letter. These guys can repeat, and these can repeat. So whatever that works out to, God only knows, and nobody really cares, right? Doesn't matter. So if you can set that up, you can plug that in your calculator and work that out. Okay? Anyways, works out to 3.41 times 10 to the negative fourth. Okay? So the probability that happens is pretty slim. Okay? 3.41 times it's 0.0000341. Very small. Okay, what if you can't repeat? Well, okay, hang on. Now we can do this with, so I have three letters. I need all the arrangements of them, right? That's 3p3. I need all arrangements of three letters. Don't have to worry about not repeating them because they can't. It's just A, B, C, right? And then I have 9 non-zero digits from which to choose. I can't repeat, so I want the arrangements of 3 from a set of 9. Okay, so there's a set of 9 digits, 1, 2, 3, 4, 5, 6, 7, 8, 9, non-zero digits. I need 3 of them. I can't repeat, so it's 9p3. On the bottom, well, it's 26p3. I need 3 from a group of 26, and I need all of the distinguishable arrangements, right? Order matters. It's a password, so you can't just type it in any order. Right? It's got to be in a specific order. And here, we get 9p3. So these guys can just cross off, right? Like if you're going to work this out, and this works out to 3.86 times 10 to the 3.846 times 10 to the negative 4. So slightly more probable, right? So what you really ask is, like, what's the probability of guessing this password? If you know it has A, B, C in any order, and then 3 non-zero digits, whether or not they can be repeated, you know, it's not likely that that's going to be guessed, right? Not if you're sitting down to do it. If you've got a machine running through it, it's not that hard, right? Like there really aren't that many possible permutations to have to run through. So it's easy to brute force some of these things, right? You just keep trying different possible combinations until you hit it. Yeah, that's it. Okay, so that's it. Yeah, let's delete that page.